So we will begin our next topic, which will be the adaptations for the continuity of life. And that basically falls under the theory of evolution. And it is quite a concept. And we're going to look at the processes that this theory came about, and then look at the evidence that lets us understand how evolution functions. Now, the man typically credited with the theory of evolution is Charles Darwin, a British naturalist who lived from 1809 to 1882. And we typically end up lumping evolution under the idea and concept of natural selection, which is basically summarized by the phrase survival of the fittest. Now, Darwin came from a very wealthy family. He attended Cambridge in England, and he was not very adept as a student, typically bored with the basic understanding and concepts that were being taught. He struggled to get C's and eventually was offered an opportunity to take a journey on a boat called the HMS Beagle. And we'll talk about how that process led to his discoveries and his understanding of the processes that lead to natural selection. Now, Darwin was influenced by a great many people, and it came from many ideas that were shared that we deal with to understand how evolution can be processed and how evolution works. Now, one of the main understandings that Darwin came to understand was the ideas of Thomas Robert Malthus, who was a British economist. He studied populations and competitions within populations, understanding how food supply directly was related to population growth and how population growth could be affected by drought, famine, or overabundance of food. From that understanding, Darwin came to understand how competition was key to survival on Earth. Another man that Darwin was influenced by was Charles Lyell, who was a geologist studying the principles of geology. Basically, what Lyell was able to do for Darwin was free up time. Prior to this, many people tried to fit the ideas of evolution and change and where life came from and how it adapted into a 6,000 year window, which was the age of the earth as calculated by Archbishop Usher. And he arrived at those 6,000 years by calculating the ages of the prophets in the Bible. We know that there is evidence, both fossil records and evolutionary evidence, that tell us that the Earth is much older than 6,000 years. Lyell put that at a few million years, which gave much more time for processes to be slow and deliberate in the theory of evolution. Today we know that the Earth is more like 6 billion years old, which gives us even more time for all of the adaptations and changes that have taken place in the tree of life. Many of these ideas are, of course, found in the fossil record, and that fossil record was cataloged and explained by a man named Georges Cuvier. And Cuvier is responsible for understanding how the strata, the layers of the Earth's crust, and the fossils found within those layers are key to understanding the age of the Earth and the age of life on Earth. So when we look at the layers of the earth from, say, for instance, the Grand Canyon, and we see the changes of those layers over time, and the compression of the minerals that make up those layers, and the fossils that can be found in those layers, this gives us a record book of how the earth was formed and how life on earth has changed and adapted. We do this too when we were looking at the magical forest. If we remember back to that documentary, we saw that the age of the earth and the age of life on earth and how things have changed are written in the rings of the trees. So this same idea of the layers that are laid down in life and on the earth give us that fossil record, that understanding of how life has changed and how the earth has changed over time. The last major influence on Darwin was Jean-Baptiste Lamarck, who was a French theorist who came up with the idea of the theory of use and disuse. And basically, what Lamarck was trying to explain was how evolution could take place in that short period of time, as outlined by Archbishop Usher's dating of the Earth to 6,000 years. So Lamarck was basically saying that if you used something or you changed something in one lifetime, those traits would be passed immediately to offspring. So basically, that's the understanding that if you, say for instance, went on a honeymoon after your wedding and you happened to go to Hawaii, and while in Hawaii you got a very nice tan, but you also conceived a child, your child would also be tan. He basically had to try to show all the changes of the earth and life on earth in those 6,000 years. So he did it basically by explaining that when giraffes eat leaves off of a eucalyptus tree, those giraffes that stretched to get the leaves at the top of the tree, they would gain longer neck muscles and longer neck bones, and those longer neck bones would be passed on to their offspring immediately. Now we know that this doesn't take place, that evolution is a long, slow process, and this process is change over time, and that time is not 6,000 years, but 6 million to 6 billion years. So while Lamarck had some good ideas about how adaptations and changes in life forms are passed to their offspring, we know that this is not something that is immediate. But it did have an influence on Darwin. So as I said earlier, Darwin left college at Cambridge and was given a job on a ship called the HMS Beagle, where he became the ship's naturalist. His job was to map the southern coast of South America, and part of what the HMS Beagle was going to do was try to regulate timepieces so that when Britain traded with other parts of the world, that the time that they were discussing could be monitored correctly. Now, one of the great things about this journey on the HMS Beagle was they passed through an area called the Galapagos Islands, which is directly off the west coast of South America, off of the country of Ecuador. And this is probably one of nature's greatest natural laboratories. So as we see, this journey takes place by traveling around from England around the southern tip of South America, past the Galapagos Islands, heading up towards the equator, then over to Australia, then below Africa, and then back up to Britain. Now, Darwin took this trip 3 times, and on 2 of the trips, he actually stayed in South America and on the Galapagos Islands so that he could gather more data, gather specimens, study the flora and fauna, the plants and animals of the region. But the greatest area of study for Darwin was the Galapagos. Now, the Galapagos is a great group of islands, and what makes them so great for nature's laboratory is the fact that these islands are very close together geographically, but the islands are very distinct. One island may be lush and green and covered with trees and bushes and all kinds of flowers and flora and fauna and fruit. while another may be dry and desolate, more desert-like, and then you may have an island that's simply composed of lava rock from volcanic eruptions. Because of this, you have very unique geographical settings that affect the way animals have adapted. And the three primary studies that Darwin did on the Galapagos included the study of tortoises, study of iguanas, and the study of birds called Darwin's finches now. Finches are very small birds. Now, the wonderful thing about this laboratory is you could have iguanas, and on those dry, desolate lava rock islands, you would have very large, brown, very plated in their skin and flesh, being very rough, and they would feed by diving into the water and feeding on the algae that grows on the rocky shores of these islands. They would have long claws so they could grip the rocks when they are feeding underwater. They would be very large with large tails that would allow them to swim very rapidly through the cold water. But then you would go to a green tropical island, and that island would have very small iguanas that are able to hide in the trees, have very narrow mouths that feed on fruit and nuts and berries, and a very different situation. As far as the tortoises, tortoises on islands that are green and lush would have very domed, large shells with very short necks because they could feed on the green, lush vegetation that's available all over the island. While on a drier island, you would have tortoises that have a more saddle-shaped shell and very long necks so that they could reach up and feed on the shrubbery that was taller on those drier islands. And then looking at finches, you would look at the finches and you would look at the fact that where there were nuts and berries, you would have beaks that were more like parrots to crush the shells of the nuts and chew on the berries. But if you had a finch on an island that had a lot of cacti, these finches would have very sharp, narrow beaks so that they could work their beak between the tines of the cactus and reach the fleshy meat of the cactus and feed on that. So this set of islands created a wonderful natural laboratory for Darwin to do his studies. Now, these are not the only things that Darwin studied. Darwin was affected by being part of an earthquake in South America and understanding how the strata of the earth could be shifted because of that earthquake. He also studied fossil remains and understood that animals that were in the South America region had similarities to animals that were found in Australia. So it is a very unique way to study. And Darwin was voracious in his gathering of samples and data. And one of the things before he went on this trip, when he was in college, he became fascinated by beetles and became an entomologist studying the lives and the features and functions of beetles and how they survived. And then when he returned home, he did a great amount of study of barnacles on the bottom of that attached to ships and rocks. And he was just a tremendous naturalist in gathering as many samples and amounts of evidence as he could compile. So please go on to the second video, which will discuss the theory of natural selection and the evidence used to figure out how this survival for the fittest takes place in Darwin's eyes, and how Darwin came up with his eventual theory of natural selection.